All right, in question number 2, we have two girls. The question tells us that they have different masses. So one of them has a mass of 60 kilograms, one of them has a mass of 40 kilograms. And then it also says one of the girls pushes on the other one with a force of 360 newtons. So let's say that is a force of 360 newtons. Okay, now from Newton's third law, we know that whether she intended it or not, when she applied a force to the 40 kilogram girl, the 40 kilogram girl applies an equal and opposite reaction force to the first girl. So this is also going to be a force of 360 newtons. It's opposite in direction, but equal in magnitude. So the question is, what is each girl's acceleration in part A? So let's take a look at this and see if we can figure it out. So first of all, drawing the free body diagram. For the first girl, she's, as it says, 60 kilograms, and she experiences this force pushing her this way, and that is a 360 Newton force. It's on ice. They tell us it's essentially frictionless, so we're just going to ignore friction. So looking at the first girl, we see that if we do the F, let's do this. If we go F net equals MA equals the sum of the forces, which equals MA. So then in this case, the sum of the forces is simply 360 newtons, but it's negative because I think I'm going to decide on making a sign convention for this whole problem. We'll make the right positive and the left negative. So negative 360 is equal to the mass, which for this girl, it's 60 kilograms times A. So then A is just negative 360 divided by 60, which is negative 9 meters per second. Nope, negative 6 meters per second squared. And now, looking at the second girl, she has a mass of 40 kilograms. So it's the same physics. We have F net equals MA. And then in this case, the force acting on her is 360 newtons to the right. So we have the sum of the forces is 360 newtons, and that equals her mass, which is 40 times A. So now in this case, A equals 9 meters per second squared. You can see from the way I drew my diagram and the way I define my sign convention, I've actually got my accelerations opposite what the answer says. But the main thing is that the signs are opposite. So all it means is that when I did this question the first time, whenever I wrote it, I had the 40 kilogram girl on the other side and the 60 kilogram girl over there. So either way, it doesn't really make sense. It doesn't make a difference. So for part B and part C, these are strictly kinematics problems. So just to quickly set it up, but I don't think I'll go through the whole thing in the video because you've seen it before. We can set up a set of unknowns. So for each girl, I'm going to say my delta x, delta t, v naught, v, and a for both of them. V naught, v, and a. So what we can see from the question, it says that the push is applied for 0.1 seconds in both cases, 0.1 seconds. And their speeds start from rest, so they start from 0, and we know their accelerations. This one has an acceleration of negative 6 meters per second squared. This one has an acceleration of 9 meters per second squared. So, I mean, in the part B, they want the velocity, and part C, they want the distance. So we need both of these. So we just take turns. In the first question, this might be my, what is it? Is it B, velocity? This is my don't know, don't care. This is my unknown. And then I can reverse them. Don't know, don't care. This is my unknown. So for the first, for part B, I'm going to use the equation that doesn't have delta x in it. So V equals V naught plus A delta T. And then for part C, it's just reversing, right? You want to know this. You don't care about this. So this is for part C. Don't know, don't care. So the equation without V in it you know that one really well. It's just delta x equals VO delta t plus 1/2 A delta t squared. So you can apply both of those equations 2 times to get the different answers. I won't go through the whole thing here, but the answers are on the board. And just remember that the negative signs are reversed. So for my solutions that I'm doing here.